Everybody is looking for green and reliable energy at an accessible cost. That's why customers are installing more and more distributed energy resources such as solar panel, energy storage system, combined heat and power, manageable loads, and more. Those distributed energy resources can then form what we call a microgrid, which can be either connected to the grid but with islanding capabilities, or purely off-grid. We at Schneider Electric believe in innovation, and we understand how critical it is to better integrate and optimize distributed energy resources in order to help our customers to reduce their energy costs, better integrate renewables, and increase their energy reliability. We have been working on different solutions for DER integration and optimization over the past years, and we are testing and developing some of those solutions here in our Microgrid lab in Grenoble, France. Let's take a tour.
Schneider Electric has designed a smart, simple microgrid architecture to meet the wide variety of customer needs. It has 4 layers to cover the different use cases, ranging from a standalone PV farm up to complex multi-energy smart microgrid. And this microgrid architecture fits in the open IoT-enabled framework called EcoStructure. The foundation to assemble connected equipment, powerful edge control, and analytics. The Microgrid Lab here illustrates how advanced solutions can tackle technical challenges related to each layer. Safe electrical distribution, combination of distributed energy resources to maximize renewable penetration, or energy management leveraging forecast to optimize the use of flexible resources.
Local renewable generation and storage change the electrical installation fundamentals, in particular the protection system. One of our challenges will be to detect electrical faults, as short-circuit currents will be lower and depending on the operating sources.
In this Microgrid lab, we are testing new smarter protection devices which are based on adaptive settings. For example, settings are dependent to operating mode, voltage level or other factors, and with this new device, Microgrid will be well protected in all its operating modes.
One of our objectives today is to increase the proportion of renewable power generation in microgrids. This means replacing the traditional rotating machines of the gensets by renewable power sources interfaced to the microgrid by means of inverters. However, if traditional grid-tie inverters are used for this purpose, the microgrid can become highly unstable for many reasons. The lack of inertia that was initially provided by the rotating machines we want to replace, the fact that traditional grid-tie inverters are not grid-forming, and obviously the fact that the PV or wind power sources are intermittent. To solve these problems, we have developed the virtual synchronous generator inverter, which consists of some renewable power source, some power storage, and smart inverter that mimics the behavior of real gensets.
Even when renewable generation is able to behave as a genset, we still need to coordinate the multiple energy sources in order to ensure the frequency and voltage regulation while maximizing the use of renewable energy.
This is the role of the microgrid controller that manages power flows in the entire microgrid, using short-term prediction in order to make decisions about reserves, cope with intermittency, and at the end, boost the use of green energy.
In a microgrid, energy resources are fully distributed. We answer questions about how to coordinate energy resources, how to store energy, when to use stored energy, and when to buy energy from the grid. In addition, microgrids bring opportunities to generate flexibilities, either by demand modulation or by storage. But how to activate them? Our answer is based on analytic services to predict loads and renewables, and to use model predictive control to manage energy flows in the microgrid and to maximize its efficiency.
We implement our advanced algorithm on a pilot project and co-innovate with our customers. For example, we implemented our model predictive control solution to manage the energy flows at the IMT campus here in Grenoble, within a customer project called Learning Grid by Grenoble. It nicely showcases a number of microgrid technologies, including energy storage, a combined and heat power plant, solar panels, and the interconnection between the two energy networks.
Each microgrid project varies in terms of weather, energy demand, energy rate model, type of asset, incentive and business model. identifying the best configuration and size of the asset, evaluating the viability of the project is a complex task, especially when you want to use advanced energy management solution. So there is a need for design and sizing tools that will be used by our sales force to optimize the microgrid design for a given customer. And a common limitation of existing sizing tool for microgrid is the fact that the user is not able to specify its own energy management solution, which is a key differentiator for Schneider Electric. So to overcome this limitation, we are working on the delivery of sizing tools that will include our commercial and research energy management solution. And the first version of this tool are now ready to be used by our colleague in the US.
In order to tackle those challenges, we decided to set up a microgrid technology program with a clear objective to differentiate through innovation. We have here a great opportunity to impact our customers, and innovation teams are very excited to take this opportunity. This innovation program combines ingredients such as innovation, academic research, prototyping, and strong connections with our businesses and, more importantly, connections with our customers. It is also important in the context of customers who are moving fast to be able to combine long-term efforts and operational support to our front office.
Now you know what we are up to regarding cutting-edge microgrid development. If you want more information, we just released new white papers regarding microgrids, and you can visit as well our website schneider-electric.com, where you can find videos, contact information and more. While you're there, you can learn as well about EcoStructure, our IoT platform that we use to drive microgrids and other innovations.